Hey guys, it's Mr. Wigand. Today we're going to look at linear equations. And we're going to look at three forms of linear equations. Slope-intercept form, point-slope form, and standard form. Alright, first off, slope-intercept form. This is usually the first form that you learn about. And the form is y equals mx plus b, where m is the slope and b is the y-intercept. Alright, so if I wanted to write an equation in slope-intercept form, these are the two things I would need. The y value and the x value would remain just those variables, y and x. And then I would need a number to represent the slope and a number to represent the y-intercept. So let's say I have a problem where I'm given a slope of, let's say, 2. And my y-intercept is 6. So if I wanted to write an equation with this information, y equals m, my slope is m, 2, x, plus my y-intercept is 6, 6. And that's my equation in slope-intercept form. Now let's say I'm given a slope equal to, let's do a fraction, 1/2, and my y-intercept is equal to -2. Right, now y equals m slope 1/2, x, remember the variables y and x stay just variables, but now instead of plus b, since my y-intercept is -2, I could write plus -2 or simply -2. I like to write it as just -2. I think it's a little neater. Alright, now what if you aren't given a slope and the point? What if you're only given 2 points? And I still want to write an equation in slope-intercept form. So let's make up 2 points. So 3 has 7, and let's say 5 and 11. Alright, to write an equation in slope-intercept form, I need a slope and I need a y-intercept. I don't have either of those. So I'm going to figure out the slope. We know that slope is y2 minus y1 over x2 minus x1. So I'll call this my x2, y2, and this will be my x1, y1. So 11 minus 7 over 5 minus 3. I get 4 over 2, which is 2. So now I have a slope of 2. Still need a y-intercept though. What I then do is I check to see if one of those points that is given is the y-intercept. Turns out it's not. Sometimes they'll give you the y-intercept. So now I have to figure out the y-intercept. Alright, so what I'm going to do is I'm going to use this slope-intercept form, and I'm going to put 2 in for m, and then I'm going to choose one of these 2 points. I'm going to choose this point. Doesn't matter which one, you'll get the same answer either way. And this is an x value and this is a y value. I'm going to plug them in for x and y. Then I'll only have one variable to solve for. Okay? It's okay to plug numbers in for x and y. It's just when you write your final equation of the line, the y and the x have to be there as variables. So y, my 7 value, equals m, my slope is 2, I found that out, x is 3, plus b. 2 times 3 is 6. Okay, now I'm going to solve. Subtract 6 on both sides, and b equals 1. So now I have a slope of 2, a y-intercept or a b value of 1. So my equation, y equals m2, x plus b, 1. And then that's my equation, y equals 2x plus 1. Okay? So I always need a slope, and I always need a y-intercept anytime I want to write an equation in slope-intercept form. Alright, next form, point slope form. Y minus y1 equals m times the quantity x minus x1. Alright, when I'm using point slope form, and the reason it's called point slope form is because I can write this when I'm given a point. So let's say 5, 3, and the slope. Let's say we have a slope equal to 4. Alright, so here's an x and here's a y. These are going to be substituted in for my y1 and my x1. So just like in slope-intercept where the x and the y stay variables, same thing here. So the x and the y that I'm going to use go in for the y1 and the x1. So y minus y1, which is 3, equals m times the quantity x minus, oh, I'm sorry, not m, silly me. M is our slope. Our slope was 4, so I'm going to put a 4 there. Times the quantity x minus our x value of 5. And then that's it. That's the answer. I know at this point a lot of people will look at it and say, well, there's some work I can do. I can distribute this 4. I can maybe add 3 to both sides to get y by itself, but you would only do that if you wanted to change this into slope-intercept form, but no need to. This is point slope form, and just leave it the way it is. Okay? Point slope form is great when you're given a point and a slope. Slope-intercept form, also great, but it's better when you have the slope and the y-intercept. So two different forms of a way you can write a linear equation depending on what kind of information you're given. All right, now, if I were not given a point and the slope, let's say like in the last problem that we're looking at with the slope-intercept, I was given 2 points. Well, I would do the same thing I did there. I would find the slope of those 2 points, then that would be my m value, and I would take one of those 2 points and I would substitute them in for y1 and x1. Okay, so same idea. All right, our third form for an equation of a line is called standard form. Now, standard form looks a little different, but once again, we're going to have an x and a y, and they're going to stay variables. We're going to have numbers representing the a, b, and the c. Couple rules. A, b, and c have to all be real numbers, and a and b cannot equal 0. Okay? Anything other than that, a and b can be any number other than 0 as long as a, b, and c are all real numbers. Okay, so an example of what this would look like would be this. 3x plus 5y equals 8. That will be an equation in standard form. My a value is 3, my b value is 5, my c value is 8. Standard form. Okay? Standard form, I could also write an infinite number of other equations in standard form that are equivalent to this one by simply multiplying everything by the same number. So let's say I multiply everything by 2. 2 times 3x is 6x, plus 2 times 5y is 10y, equals 2 times 8 is 16. Now I have another equation in standard form. It looks different than this one, but since I multiplied everything by the same factor, these two are equal. And I can just keep going on and on. I can multiply by 3, I can multiply by 4. Sometimes you'll get equations like this. 4x plus 8y equals 6. And now not only could I multiply everything by the same number to get an equivalent equation, this one, since all 3 of these are divisible by 2, I can divide the whole thing by 2. 4x divided by 2 is 2x. 8y divided by 2 is 4y. And 6 divided by 2 is 3. So now I have an equivalent equation to this one here. Looks different, but they are equal. And if you're not sure, plug values in for x and y to find out what equals 6, and then the same xy values will work down here. All right, now standard form. A lot of times you will want to write an equation in standard form, but you're not given information that's going to easily make it easy for you to write in the standard form. So let's say I'm given, I don't know, a point 2 comma 3, and I'm given a slope equal to 4. The directions are for me to write an equation in standard form. Well, if I'm given a point, I'm given a slope, common sense tells me I'm going to use point slope form. So y minus y1, 3, equals m, or slope, 4, times x minus x1, 2. Okay, I want to put this into that form, so I need to get all the x values over here, all the constant numbers over here. So let me distribute this 4 first. 4x minus 8. I'll have my y minus 3 over here. I'll subtract 4x on both sides so that I can get my x values on the left side. Negative 4x, and that's important because it's ax plus by. The x value should come first. Plus y minus 3. That'll cancel, and I'll be left with negative 8. Now it's just a matter of getting this over here. Add 3 to both sides. And I'll rewrite over here. Negative 4x plus y equals negative 8 plus 3 is negative 5. And now my equation is in standard form just by doing a little work, a little inverse operation. So we have 3 different forms that we're looking at for equations of lines. Slope-intercept we usually start with, point slope form, standard form. Slope-intercept is good when we have the slope of a line and the y-intercept. Point slope form is good when we have a point and the slope. And then standard form, I can really write from either of those 2 other equations, just depending on what the information was I was given to start. Right? Good luck with those 3 different forms of equations of lines.